Hey guys, it's time to do Chapter 3, pages 65 to 73 sticky notes on, this will be section 2 on biogeochemical cycles. So it actually starts right here at the bottom of page 65. So just a tiny little bit, and then we move on to the next page. Okay. So on page 66, it kind of talks about biogeochemical cycles just in general. And sorry, I'm just trying to get adjusted, deal with the movements of matter within and between ecosystems. And we know about matter being a closed system on Earth. So we know that it's this continuous cycle. And so this actually, it's called biogeochemical because it includes biological, geological, and chemical processes. So it's more than just rocks, or it's more than just living things. It's just all of it together. All right, so a couple terms I just want to point out, and they may not be as specific in the book, is that reservoirs, sinks, and sources. Those are terms used a lot. And a reservoir or a sink is where nutrient is stored. And a sink would be like a long-term, like the ocean is the biggest carbon sink. So long-term storage would be a sink. Sometimes people just call it reservoir too. But anywhere where the nutrient like stays or is stored. Now, so sources release more than they absorb. So a good example of that would be animals, humans, things like that. Okay, so then the chapter goes into the 4 major cycles that you guys need to know: hydrologic cycle, carbon cycle, nitrogen cycle, and phosphorus cycle. So for each cycle, this is what I want you to focus on. I want you to, and you can make your own sticky note. You know, like I would take this as kind of like a template, but for each cycle, you want to look at the importance of the nutrient. Why is it important? What is it needed for? What are the processes that transfer the nutrient from place to place? What are the reservoirs? So where is it stored? And typically we're looking for like the biggest one. And then what's the human impact on this particular cycle? So there's 4 of them, okay? So I want you to do this for all 4 of these while reading the chapter, okay? So for the water cycle, we all know that water is super important. Here's a really good figure for the water cycle. So knowing the processes, evaporation, precipitation, those kinds of things, and then how it moves, and that here's just an additional post-it with just a few things I just wanted to highlight. That to remember that the hydrologic cycle is powered by the sun. So it's determined by the sun. That's what makes it go. And that the oceans is the primary reservoir for water. That makes sense. And that ice caps and groundwater are much smaller reservoirs. Okay, so this is just kind of added on. This was in the College Board. I just wanted to make sure that you have it in the same place. Okay, so again, make sure that you're doing this, using this template kind of to make your own. All right, then we get into the carbon cycle, and this is a biggie, especially with photosynthesis, respiration, combustion. And just a few things to add, just to make sure to look at a carbon cycle. You've got short-term reservoirs and long-term reservoirs. And short-term would be like things that do photosynthesis and things that do cellular respiration and combustion. These are processes that release carbon pretty quickly. And then these long-term reservoirs like oceans and fossil fuels, they hold on to the carbon for a long time. And then these processes like kind of move it around. Okay. So again, this is a really good figure for the carbon cycle. So you need to understand the movement of water, photosynthesis, respiration, combustion, burial, exchange. So when I ask you about the processes, they'll tell you, and you can see it right here, it says, Figure 3.11 discusses the 6 processes that drive the carbon cycle: photosynthesis, respiration, exchange, sedimentation, burial, extraction, and combustion. So those are your 6 processes. And then you need to make sure you understand each one. All right, so you can use this picture, and then there's quite a bit of information on carbon, especially the human impact. All right, then we move into the nitrogen cycle. This is typically the hardest one to understand. There's a lot of information, and this is a very good figure, especially this part down at the bottom where it tells you what's happening at each part. Okay, and so realize that nitrogen, its main reservoir is in the atmosphere, and then everything else holds it pretty much for a short period of time. You can see that this is my little additional post-it note based on what the College Board says. Okay, so this is just an addition to, it is covered in the book too. But so nitrogen fixation is the only way that nitrogen can be taken from the atmosphere and then made into a usable form, because we can't breathe in nitrogen. We can't use it when we breathe it in. There's two ways that nitrogen can get taken from the atmosphere. The biotic way is by bacteria, and then the abiotic way would be through lightning. Okay, so we'll do a lot more practice with this one in class, but it's really important that you have a good understanding of what's going on. Okay, so do the processes. All right, moving on to the phosphorus cycle. Phosphorus cycle, this is additional information from the College Board. I just wanted to make sure, just to highlight it. There is no atmospheric phosphorus. There is no phosphorus in the atmosphere. Its major reservoirs are rocks and sediments. And phosphorus is a limiting factor, which means that if you have too much of it, it can, well, if you don't have enough, it can limit growth. Because it's needed for, especially for plant growth, and as is nitrogen. So a good figure for phosphorus cycle. So do the, get the processes, figure out the reservoirs. You've got fertilizers, detergents, and all these different ways that, that the phosphorus gets put into the waterways, dissolves in the ocean, and then gets buried as sediment, and those become rocks. And then over time, long time, you've got geologic uplift, which pushes the rocks up, as mountains and things like that. So then rocks, remember, are the largest reservoir. And so then once these get weathered and like rained on and stuff, the phosphorus comes out of the rocks and then, kind of washes in or is taken up by plants, that kind of thing. Okay. And then it does briefly talk about calcium, magnesium, potassium, and sulfur. The only one that we'll kind of talk about later when we cover air pollution would be sulfur. So that is something we'll get into later. So it's just the big four: water, carbon, nitrogen, and phosphorus. Okay, so just a reminder, make sure that you add these kind of additional stickies in, or even on your own sheet of paper, to focus on the importance, the processes, the reservoirs, and the human impact. And that is it. See you next time.